Before drawing the actual indicator diagram, we are going to discuss the actual indicator diagram in detail. But before that, we will try to see the reasons for the variation between the theoretical indicator diagram and the actual indicator diagram. Why the actual indicator diagram is different from the theoretical indicator diagram? What are the practical reasons which deviate the actual indicator diagram from the theoretical indicator diagram? So the deviation of this actual indicator diagram from the theoretical indicator diagram is due to some reasons like the inertia effect. First of all, inertia effect. So what is this inertia effect? Any substance will try to maintain its state of rest or its state of motion. So that is nothing but the inertia of any body, any object or any substance. So when the air is flowing inside the engine cylinder, that will take some time. Instantly the air will not try to enter inside the engine cylinder, and when it starts entering the engine cylinder, it will not stop instantly. The valve will not open all of a sudden, and valve cannot be closed all of a sudden. So there is always inertia effect present in every motion. So due to this inertia effect, you will find that there is a change between the theoretical and the actual indicator diagram. The corners are rounded, lines are not straight, we don't get the sharp edges, sharp lines, and we don't get the sharp corners also. We get the rounded corners in the actual indicator diagram. Due to friction also, you will find that there are actual variations in the pressure. The value of pressure may not be exactly as it is predicted theoretically due to the friction which is present between all the moving surfaces. The valves are moving when they are being closed or being opened, and moreover, when the fresh charge is entering inside the engine cylinder, or say air is entering inside the engine cylinder, there is friction between this entering air and the small opening of the inlet valve. Similarly, when the exhaust gases are moving out of the engine cylinder, there is friction between these exhaust gases and the small opening of the exhaust valve. So due to friction also, you will find that there is a practical deviation in the pressure, and therefore the actual indicator diagram differs from the theoretical indicator diagram. The valves are also providing resistance to the flow of the charge inside the cylinder or to the flow of the exhaust gases outside the cylinder. So this is also the reason for the deviation. Then there is always some time delay. You will find that the engine rotation speed is very high, and even if the valve opening starts at a particular instant, it will keep on opening till the valve opens fully. You will find that the rotation of the crank is something like 10 degrees, 20 degrees, 25 degrees, or even 30 degrees. So though the valve opens quickly, but still during the quick opening of the valve, there is a sufficient rotation of the crank, because the speed of the rotation of the crank is quite high, and this will induce the time delay. Relative time delay is induced in the various processes like the opening and the closing of the valves in the working of the IC engine. So I told you that valves will not open or close instantly, and therefore the corners are rounded. The corners of the actual indicator diagram are rounded. One more important thing is about the pumping loss. When the air is entering inside the engine cylinder, you will find that there will be pressure difference. Without pressure difference, flow of air or any fluid is not possible. So whenever the pressure inside the engine cylinder is less than atmospheric pressure, then only the air from atmosphere can enter inside the engine cylinder, or the exhaust gases can move outside the engine cylinder only if the pressure inside the engine cylinder is more than the atmospheric pressure. Therefore, some power is required, some power is lost in driving the exhaust gases outside the engine cylinder, as well as in sucking or allowing the fresh charge to enter inside the engine cylinder. Some power is lost, and that loss is called as the pumping loss. During compression also there is a pumping loss. So these are the reasons why the actual indicator diagram is different from the theoretical indicator diagram. Now let us study the actual indicator diagram. So that is important for us right now. So this is the PV diagram. Pressure is plotted on the y-axis, volume is plotted on the x-axis. And here you can see this TDC. TDC means top dead center and BDC means bottom dead center. These are the two extreme positions of the piston. When the piston is at the top, extreme top position means towards the engine cylinder head, that is the top dead center. And when the position of the piston is towards the crankcase, extremely towards the crankcase, that is nothing but the bottom dead center. So the volume varies from TDC to BDC, and the pressure is plotted on the y-axis, and actually here we are showing the variation in the pressure as well as the volume according to the variation in the crank angle. So from TDC to BDC, the crank angle is 180 degrees. So let us see the various processes, or the before that some short forms you should know. IVC is nothing but inlet valve open, IVO is inlet valve closed, FVO is fuel valve open, FVC is fuel valve closed, EVO exhaust valve open, EVC exhaust valve closed. So this center line which is shown, horizontal center line which is shown, is nothing but the atmospheric pressure line. So we know that the atmospheric pressure is supposed to be constant, so therefore this line is horizontal and this is our reference line, and we start from this line. Okay, the first process is suction process. It starts with the opening of the inlet valve. IVO means inlet valve open. So at point 1, but actually inlet valve opens before point 1. Point 1 indicates the position of the piston at TDC, top dead center. But before that, some angle, small angle before that, the inlet valve is opened, and then when the inlet valve opens and the piston is moving from the top dead center to bottom dead center, the suction stroke takes place. So this is the suction process, suction stroke from 1 to 2, and you can see this curve which represents the suction is below the atmospheric pressure line. Practically, in practical or actual indicator diagram, this line is not matching, not overlapping with the atmospheric pressure line. It is below the atmospheric pressure line. The reason is that the pressure inside the engine cylinder must be below atmospheric pressure, then only the air from atmosphere or the fresh charge will enter inside the engine cylinder. Moreover, some resistance is also offered by the inlet valve to the flow of the air inside the engine cylinder. Therefore, definitely the pressure inside the cylinder should be sufficiently less than the atmospheric pressure. Then only the air from the atmosphere will enter inside the engine cylinder. At point 1, if you observe minutely, at point 1, the difference is almost 0. So the entry will start later on when the piston is moving from the top dead center to the bottom dead center. Then the pressure is reduced, suction is created, pressure is reduced, and due to the reduction in pressure, the entry of the fresh charge starts, and the fresh charge enters inside the engine cylinder. During the suction stroke, the piston stops at point 2, that is at BDC, and the entry of the fresh charge will also stop at point 2, but actually you will find that due to inertia effect, this fresh charge keeps on entering inside the engine cylinder beyond point 2, and therefore the inlet valve is closed after some time, not exactly at BDC, but after some angle after BDC, the inlet valve is closed so that some additional fresh charge can enter inside the cylinder even after the piston is at BDC, and from point 2 to point 3, the piston is again moving from BDC to TDC, from bottom dead center to top dead center, and during this motion of the piston, compression of the fresh charge takes place. Inlet valve is closed after some angle from BDC, and then you will find that both the valves remain closed. Therefore, the air has no other way than to get compressed inside the engine cylinder. Now, before the compression stroke has ended, the fuel valve opens. Fuel valve opens slightly before the end of the compression stroke, and here you will find that it is shown that the fuel valve opens, and after that you will find that at point 4 the fuel valve is closed. Fuel valve is closed at point 4. So fuel is being supplied during the motion 3-4. So actually 3-4 is supposed to be the heat addition at constant pressure. The process of heat addition at constant pressure, because at point 3 the fuel injection start, at point 4 the fuel injection will stop. Now this is the diesel engine. So if you consider the compression ignition engine, you will find that at point 3, as soon as the fuel is injected, burning of the fuel will start. There is no spark produced. Spark is not required here, because in the compression ignition engines the pressure ratio is very high, and due to the very high pressure ratio, the temperature is also very high. Pressure is very high, temperature is also very high. The temperature is higher than the ignition temperature of the fuel. So the ignition of the fuel starts as soon as it is injected inside the engine cylinder. From point 3 it starts, and the fuel injection stops at point 4. But after that the expansion stroke takes place. So what is happening here, that due to the combustion of the fuel, there is an explosion and there is a tremendous increase in the pressure. So a lot of force is acted on the piston. So the piston is pushed away from the top dead center towards the bottom dead center, and thus a lot of power is produced during this stroke. So this is the only stroke, that is the expansion stroke or power stroke, during which power is produced and the value of pressure is high. But since the expansion process takes place, you will find that the pressure goes on decreasing during the expansion process, but the piston is moving from the top dead center to the bottom dead center, and force is acted on the piston, therefore power is being produced. So this is the expansion process 4-5. Now here what is happening is that the exhaust valve opens slightly before the expansion stroke, so that maximum exit of the exhaust gases is possible. So the exhaust valve is open slightly before, and the exhaust will start. Sufficient time can be given for the exhaust of the exhaust gases, and of course some time is required for the opening also, and therefore we try to open the exhaust valve slightly before the piston reaches BDC position. Now after this we have the exhaust stroke, because the exhaust valve has been opened and the piston is now moving from the bottom dead center to the top dead center. So the volume is being decreased, and the exhaust valve, since it is open, the exhaust gases have no other way than to move out of the engine cylinder, and the exhaust gases will move out of the engine cylinder. But look at this line 51. This line 51, which represent the exhaust of the gases, it is lying slightly above the atmospheric pressure line. It indicates that during the exhaust stroke, the pressure inside the engine cylinder is slightly higher than the atmospheric pressure. So this is required, because then only what will happen is that the exhaust gases can move out of the engine cylinder. Otherwise the exhaust gases will not move out of the engine cylinder. So the exhaust gases are now moving out of the engine cylinder during the exhaust stroke, and the piston is now at the top dead center position, but the exhaust valve will not close exactly when the piston is at top dead center position, but after some angle rotation of the crank, the exhaust valve will be closed. It is shown by this small blue cross which is on this curve, because after exhaust again the suction stroke starts. So this exhaust valve is closed slightly after the top dead center position, allowing more exhaust gases to leave the engine cylinder. And here you can now understand that after exhaust stroke the suction stroke takes place. So when the exhaust stroke ends, before the end of the exhaust stroke, the inlet valve is open. That means inlet valve also opens slightly before the top dead center position, and the exhaust valve is closed slightly after the top dead center position. So the valves in the actual engine, they are not exactly opening and closing at the top dead center position or the bottom dead center position like the theoretical case, but in the practical or the actual case you will find that there is some angle difference, there is some lag between the top dead center or bottom dead center and the opening and the closing of the exhaust and the inlet valves. So thank you my dear student friends.